This is Gail Kovac with Gresham Barlow School District. It's summer school, high school credit recovery for geometry, and learning target number 6. I can use side, 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 angle, side, angle, and angle, angle, side to determine if triangles are congruent. By congruent, we mean exactly the same shape, same size, photocopies of each other. So we have these triangle theorems that if three sides of a triangle, if all of their sides match in length, like 3, 7, 9, and whatever, then those triangles must be exactly the same. That means their angles are going to match as well. We have side, angle, side. If we have two sides that have the same measurement and the angle between them is also the same angle measurement, then we don't even need to bother checking the third side or the other two angles. They're gonna match. We've got angle, side, angle. If we have two angles that measure the same and the side length in between those angles being the same, then those triangles will be congruent. Last one is angle, angle, side. Two angles and a side off to the side. If that amount matches within two triangles, then we can guarantee the other stuff will match as well, and those triangles will be congruent. So what we're looking to do is identify if any of those four are happening with the information we've been given to say yes or no, do we have enough information to say that these triangles are the same or not. So let's try this first pair over here on the left. Now notice that we haven't been given any measurements specifically. We've just been given these marks that indicate if sides are the same. So here I've got two triangles and I've got three pairs of marks on either side. So here I've got the 1. I don't know how long that is. Maybe it's 10 feet across, maybe it's 7 centimeters. I don't know, but whatever it is, it matches with this one over here. So those two are the same. So far we've got one pair of sides that match. We've got S. Now that's not one of my 3 up here. I need more than that. So I need something up here. So far just one S ain't gonna cut it. There's too much that's still unknown about the triangles. I could have things that don't match and then I can't guarantee that the triangles are photocopies of each other. So let's see what else we've got, because I got some more marks here. I've got another pair of sides. Here's a 2, and this matches with this 2 down here. So those two sides, they also match in length. Again, maybe they're 3 miles across, maybe they're 18 yards. I don't know. All I know is that they match in length, whatever they are. So far I've got S, S. That's not one of my 3 triangle congruencies. I need one more piece of information, and I need to make sure it's one of these 4 specific scenarios that we have. So this is not enough. But I still have one piece of information given. I've got a third side length, here's side length number 3, that also matches with the same markings as this one up here. So I've got 3 sets of sides that all match. I have not been given any marks for the angles, so I have no A's within this statement. I've got 3 pairs of S's that match. And in fact, that is enough to say that the triangles are congruent, because I've got this up here, side, 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 side. This is enough to say, yes, these triangles are perfect photocopies. None of their angles are going to be off. Their angles are going to match perfectly as well. So the answer here is yes, they are congruent by side, side, side congruence. And all right, let's take a look at the next one over here. So the next one over here, let's see what we've got so far. All right, so I'm seeing some more tick marks. I'm seeing this on this side length, that's a 2. That matches with this one over here, that one's also a 2. So I've got one pair of sides that match perfectly. I've got S so far. All right. Gosh, I don't think I've been given any other side lengths. Yeah, the one up the top here is blank. It may match with this one down here, but they didn't mark it, so I'm not exactly sure. And I've got another side length over here. I've got this long one. And it looks like it might match with that one, but I can't trust my eyes. My eyes will be deceiving to me. I need to know by the markings, and they're not marked as congruent, so I'm not going to think that they're congruent yet. So far with sides, I've only been given one pair. Now that's not enough to say that the triangles are congruent. I don't have one congruent statement up there that just says S. But I do have another piece of information here. I've got an angle measure. In this top triangle, I've got a right 90-degree angle. In this case, I do know that angle measure. If it's a square, it's 90 degrees. And in fact, I don't even really specifically need to know that it's 90. All I need to know is that it definitely matches with this triangle here at the bottom. They are both the same. So I've got a side, and next to it, I've got an angle that matches. Now, so far, that's all I've got, side and angle. And that is not one of my 4 congruence theorems. So far, I have not enough information to say guaranteed that those triangles are exactly the same. They could be a little bit different. But there is a piece of information hidden in here that I can assume, and it is called the vertical angle theorem. When 2 straight lines, and I know that's not a straight line, but we're going to pretend, when 2 straight lines cross each other, they create angles. I sometimes call them bow tie angles across from each other that can be proven with the vertical angle theorem to be congruent to each other. So those 2 angles here will match, and this angle is going to match with this angle down here. Well, those are called vertical angles. And I'm just going to put VAT for vertical angle theorem right here. Now, I do have these 2 triangles connected with 2 straight lines here and here. So in fact, by the vertical angle theorem, this angle must match that one in its measurements in degrees. So we've got vertical angles right here. Those 2 are the same, in which case I've got another pair of angles that I know must match. But the question is this going to be angle side angle or side angle angle? Like, where does the A go here? Notice that I've got 2 theorems here that have 2 A's and an S in them, so I wonder which one we're going to use. I need to determine if I have 2 angles given and the side in between those angles given, or if I have 2 angles given and the side off to the side given. So I can see here, I believe, I have an angle, then a side, and then another angle. I have a side, an angle, a side, and then another angle given. So this is in fact angle, side, angle. Angle, side, angle. So it is like this instead. Angle, side, angle. So the question is, are these 2 triangles congruent? Do we have enough information? Yes, we do. Those triangles must match. In which case the corresponding other angles and sides will also match. The skinny one on the top and the bottom that I thought, maybe those match. Yeah, I have enough information to say, yeah, they're going to match now. As well as the long side, we call that the hypotenuse of a right triangle, and the other angle at the bottom and top. It's all going to match. And I didn't even need to calculate or check that to be sure. Now let's go on to the last set. I see 2 triangles here, and they get put together to make a quadrilateral. So let's see what information I have matching with these 2 so far. I see some tick marks. So here I've got 1 and a 1. So I've got a side. That's what I've got so far. All right, I've also got an angle here and an angle here that match. All right, so I've got a side and I've got an angle, and I haven't been given anything else. So I wonder if this one's a no. This one can't be. But if you recall, when the 2 triangles in the middle example were connected together, they were connected together by vertical angles. Well, let's see. I don't think I've got vertical angles here. No, I'm looking for that bow tie situation with two lines crossing. I don't have that here. But let's see. So no vertical angles. These two triangles, however, are still connected. And in fact, they connect by a shared side in the middle. They are both sharing this side. In which case, if that side length were 10 meters for one triangle, it's a shared side. It has to be 10 meters for the other triangle as well. So this middle shared side is congruent to itself, in which case we do have a second side length that is congruent. So let's see here now. I've got two side lengths and I've got a angle. I wonder if this is side angle side. Let me check and see. For side angle side, you need two sides that match and the angle in between them that matches. So let me see if that's the case. All right, I'm going to start with one side length. I've got a side length. Oh, and then I've got a side length, and then I've got an angle. The angle is not in between my two matching sides. Oh, okay. Yeah, let me see. Side length, and then another side length, and then an angle off to the side. Oh, shoot. I don't, in fact, have this. I've got this. Two side lengths and an angle off to the side. In fact, these colors are actually switched around if I'm color coordinating this correctly. It starts with the green side, and then it goes to the blue side, and then we have got the angle. So my angle is not in between the two side lengths, it's off to the side. And SSA is not one of my four triangle congruency theorems. So this is in fact not enough information to say the triangles are congruent. And if you're having a hard time trying to figure out which one doesn't work, I know this is like not politically correct, but I mean, if you look at this as a word and what it actually spells backwards, I'm like, oh, you're not allowed to do that in class. So yeah, that one does not work. In fact, in this one, we're going to say a big fat no, we cannot guarantee those triangles are congruent without further information. They still might be, but we just don't have enough information. So I'm going to say not enough info. They could actually create two different kinds of triangles with that set up so far of SSA and the one type of triangle is not necessarily guaranteed. So they still could be, but we just don't have enough information. But we're just going to say no for now because we're not precisely sure. So we are looking for one of these four triangle congruencies, and it is important the order in which they go in. Angle, side, angle is different from angle, angle, side, etc. But I mean, both of these would produce congruencies. What you've got to watch out for is that ASS one, which is not one that works.